This is the final design review presentation for Group CD27 for the iMakeKey Repeatable Vehicle Challenge.
This vehicle is powered by a DC motor with alkaline batteries. The DC motor will spin the gearbox system and in turn will move the rack backwards. When the vehicle hits the wall, a switch will be triggered and the rack will move in the opposite direction, which therefore causes the vehicle to move in the opposite direction as well. The rack also has stoppers which will prevent the vehicle from moving further from its original position. Firstly, we reflected on the previous scenarios week to see the improvements and adjustments we needed to make for our vehicle to function. We decided we needed a proper alignment system and a good balance between speed and efficiency.
From our previous review, we have been told that an alignment system was necessary for our vehicle. As you can see from the CAD model, springs were added to ensure the impact is softened. We have put ram bars on the front of our spring to make the vehicle align with the wall when it glides even at small angles.
In this scenario, the time taken to finish the course and efficiency was more important than the accuracy. In our first attempt, we attempted to decrease the gear ratio to get higher speeds. However, there is a minimum torque required to overcome the resistive forces. Decreasing the gear ratio caused us to go below this minimum, and thus we could not move. Therefore, we chose a gear ratio that resembled a higher efficiency, which was our original gear ratio.
As we start to add more features on the vehicle, we realized that the weight of the vehicle kept increasing. Thus, we removed some of the framework on the main body to decrease the weight and make the car look less boxy and more like a real vehicle. This also reduced the cost of the materials required to build the vehicle, which is essential for this project. Additionally, the mass of the vehicle severely affected the velocity of the vehicle.
How do we know our vehicle is going to run? We remade our previous iterative model so that it would be more accurate and we could use its data to represent what our simulation should show. As you can see from the iterative method, we should get a terminal velocity of 0.24 meters per second. We also took an estimation of what our energy consumption per unit time should look like in the iterative method. We took these values as a sanity check for when we simulated the motion of our vehicle. Next, we took the vehicle's parameters and we put them into our simulator. The results of both the iterative calculation and the simulation are shown in the same graphs. You can see that the final velocities of each simulation were off by a small margin difference of 0.01 meters per second. Our energy calculations came off slightly different. We haven't been able to work out what causes the difference, but we do think it's due to the inaccuracy of our resistive forces.
A large proportion of the vehicle is composed from the main chassis of the vehicle, especially the gearbox and the main car body framework. For this, a material that was cheap and light was needed. This is why we decided to build most of our car from ash wood. The axles responsible for turning the mechanisms needed to be a strong material capable of withstanding the turning forces from the gears, but also cheap enough for our budget. Aluminum alloy was a great choice due to its strength and cheapness as a material.
In terms of the dimension, the vehicle has a dimension in millimeters, 320 in length, 150 in width, and 135 in height, which can fit in a 400 by 400 by 400 envelope as required. A lot of the vehicle will be constructed using accurate tools that can carve into the material precisely. However, there are no complex structures that require any specialized equipment. Some of the components can be simply put together by applying strong adhesive between them.
Most of the prices comes from the main chassis of the car and the wheels of the vehicle. This is due to the large total volume of the main chassis in comparison to the rest of the car. We found a great deal with the motor, paying around £1 for it. The most expensive part we bought was a DP-DT switch, for which we paid around £4. Lastly, the grand total of the vehicle is £24.40.